Alright, I haven't ripped a LeetCode problem in about 2 months. I got the house to myself, so I figured I'd do a live solve. I'm not even gonna lie to you, I am pretty rusty. I don't do a lot of hand coding these days. I've definitely fallen into the vibe recently. But we get this array. Um, it's like parent, child, and then this is a boolean, like 1 or 0, of if it is the left child configuration. So this would be like 20 or 15 is the left child of 20, and then this would be like 17 is the right child of 20 because this is 0. And we have to use these to build the tree, but we don't know like what the root node is, and they're not in order, it doesn't seem. But we can deduce, I did figure this out, we can deduce what the root node is because it won't have a parent in the configuration. So like we got to come up with some kind of way of sorting these so that we can build the tree out. That was kind of a long-winded explanation, I guess, but let's start this timer. I'm just curious. All right, so my immediate thought was like do a left child array, or not a left child array, a left child map and a right child map, which seems pretty inefficient, but that kind of does sort of seem like it would make sense. But I'm gonna go ready, like we're kind of obviously probably gonna have to loop over, so I'm just gonna go ahead and set it up. I equals 0, I is less than description size I plus plus. So we'll have our outer loop. The good news is I don't think we have to do like an inner loop, because the size is always 3, so there's no like error checking to be done there. I guess you could if you wanted to be safe, but I'm not gonna. So I guess if any node is the child of another node, then we can push it into children, and then presumably we should be able to iterate over the range and figure out what the parent is by whichever node is not in children. That does imply that all nodes are, and these numbers are going to be big too, so I don't think that's actually very efficient. Because we're going to be checking a bunch of numbers that don't even exist, and that wouldn't work because we would hit a number that isn't even in the tree, and it would think that it would be the parent because it wouldn't be in the child, so maybe that's not the best option. I'm cooked, chat. My thought is to put all the nodes into a map, and then you can call the map if the node exists. If it doesn't exist, you can create it. But I don't quite see the end state in my head, but we're gonna try it. I'm like 2 hours, and I look up and it's like 7 minutes. All right, so my new theory, I don't know if it's right, is that we're gonna have this map with the values, because that's how we're gonna be able to reference, because they're values in the array, and then a tree node, which will be like a subtree because we can later attach through reference. Is my idea. And then a set of scenes, so every value we see as a parent, we just push into scene, and every value we see as a child as well. And then at the end, we iterate over scene, and there'll be one value that isn't also in children, and that will be the root. And then we just return that root from the map. And because we're gonna do all the left child and right child references and pointers, that should be the full tree, I think, if I remember how this works. But anyways, I'm gonna try it. I'm telling you, you don't code for a little bit, and it's like, it just leaves you. It is not like riding a bike. I mean, you can always figure it out, but the AI stuff's making us lazy, I'm telling you. All right, so if we don't already have the parent, then we have to get the parent in the tree first. So that's what we're calling create subtree for. So we'll do that. So if we don't have the parent, we create it and put it in the map. If we don't have the child, we create it and put it in the map. And then after we know that both of those are in the map, then we add the reference. So this is the left child reference because descriptions I2 is equal to 1, which would be the indicator to the left child. So we would say map descriptions I1. So we just set the left pointer within the map. So we get it from the map and then we set the left pointer, and then this. I keep trying to use Vim because I've been on that lately, but I forget that we don't have it in here. All right, so we're adding scene. Just add the parent, then we add the child, and then we also add the child to children. If we're not within this if, then we need an else to do the right child equivalent. So else. Not description, same thing. Except for, again, this is probably going to be a slow, unoptimized algorithm, but I just want to solve the damn thing. I'm rusty. All right, so same process, except we're making the right pointer because this would be the right child. We don't actually need this max one because we can iterate over the scene and just look at all the ones that we've seen already. And that's actually better because if we did that max way, we would have to hit a bunch of dead indexes. So I was wrong there. This actually doesn't need to return because it's just updating the reference to the map. So we'll say void. Void piece. Okay. We're good here. Make sure we're still compiling. We don't have any errors with all these brackets. Map count. Oh, because I just said map. I'm supposed to say piece. Once we get to this point and we break this loop, we should have everything we need, and then I think we just do for auto. I think this should work. Yeah, and then actually we never hit that. We can just leave the null if this does anything. Hey, look at that. Well, we passed the 2 base cases, so let's see. We're either going to get like a time limit exceeded, or there's going to be some edge case that I'm not accounting for. Let's give it a shot. I don't know what I just did. Hey, nice. That works, but pretty slow. We could probably optimize somehow. Let's see, because right now we're in, I guess this would be linear time. Yeah, because we're just iterating over once. Let's see, how could we optimize? You know, I forgot to stop the timer, so I have to look back at the. Oh, I did stop it. 19 minutes ain't bad, especially as rusty as I am. I'm calling it good. Could it be better? Yes. Do I care? Not really. First one in a while. And I still got it, I guess. So, have a good one. All right, I called it good, but I'm too stubborn to give up, and I went to do something else, and I couldn't stop like thinking about how there has to be a better way to do this. So we're gonna optimize it. I still haven't looked at the solutions, so I don't know the actual optimal way to do it because I'm not that smart. But I do know that this doesn't need to be in both. We can kind of just do this at the top. So that's a lot cleaner as far as that logic goes. We don't have that duplicate code, which makes me happy. Maybe we don't need to do the set thing, like there might be a better way. Like the child or the parent is in children, and if it's not, yeah, that wouldn't work. See, this is what's annoying about LeetCode is you can get a solve in a good amount of time, and then when you start trying to optimize it, like just go ahead and get ready to spend just as much time. Unless you're just a god, but I'm not. We're gonna glance. We're not gonna look at the answer, but we're just gonna look. Bit manipulation. Tree construction using hash map plus root tracking. Explain myself in a minute. I'm cooking over here. Probably cooking nothing. It might be overcooked. All right, well, you're inserting the child and you're inserting the parent. And so what if? I don't think with this approach, I don't think we need these two. Because I think what we can do is get rid of all this. When you create a new parent, then that means that's a candidate to be the root node because it won't obviously have been a child of anything else. So if the child is in the best parent set, then it's not a candidate to be the root anymore, so you have to erase it. Oh, yeah, and then I think you can just do, so essentially we're doing the same thing, but we're just doing it in a more memory friendly way because we only need one set. There we go. Hey, now I can do it. Yeah, so same approach as the unoptimized one, but I just was doing it in a stupid way because I was doing it at the end and using two sets. Really, all I had to do was check the children. So, but we're not cooked. Have a good one.